My name is Charles B. Watkins Sr., and I'll be your facilitator for the 1 hour of great fun and excitement that we're going to have today. So, again, I trust that everybody is having an outstanding day. And this is just a little bit about me. Now, I've been doing this about 2 weeks. Actually, I've been doing it a little bit longer than that. I've probably been doing this, if I got the numbers right, 27, almost 28 years. So when you look at this stuff, there's a bunch of stuff that I didn't put on there. But the one thing that is most certainly, evidently true for me is I love it. Not here. I love it. I love it. I want to make sure that if you can hear me, if everybody who can hear me would just give me a big yes in the chat, I'd appreciate it. Great, great. Awesome. Awesome. Sounding great. Awesome. Ron, I appreciate that. That check's in the mail, man. That check's in the mail. Well, we're going to jump right into everybody Python. My assumption is everybody has at least heard of it before. It's got to be one of the most outstanding things that I think is happening in programming and throughout the entire universe of what we do in IT. And so as you see here, we call it a general programming language. Now, it's an interpreted language. And what we mean by that, I'll talk about in a second. But I want you to know that Python is extremely powerful. Not only do a lot of people use it for learning purposes, but you can see that many of the major corporations are using it as well. So it is good for everything from social media, web development, data science. If you can think of something, Python potentially can facilitate it all the way through large language models. And everybody's heard of ChatGPT or Brad. I believe that is brad.google.com. There are going to be several who are coming out, but almost everyone will have some interoperability with Python. Now, one of the things that I would like to give you is just a short history. Python was invented by a guy named Guido van Rossum from the Netherlands. Yeah, he did it because he really wanted people to have a way to sort of enter into this whole programmatic universe. But C, which is what Python is based off of by default, challenging for the average person to really put their head around. So his idea was, let's create a different programming language that will encompass some of the elements of C, but maybe it won't be as hard to deal with. And so Python was born. Now, Python here doesn't really mean the snake, even though that's the icon that's used. It actually means Monty Python's Flying Circus. Now, I don't know if any of you all are even young enough to remember Monty Python's Flying Circus, but that's where he actually got the name from. And so it is what we call an object-oriented language, which we'll touch on a little bit more as we go through. Say, go away. So what is the Zen of Python? Well, here are some of the basic tenets of Python that we work with. Number one, beautiful is better than ugly. I didn't make up these tenets now. This is Guido van Rossum's Zen. And what that says is, if something looks easy to use, makes sense when you see it, it's better to do it that way. Why does it have to look complicated? If any of you all have experience with any other programming languages, you will know some of these languages can look really interesting. When you start working with C, C++, C#, God bless America, assembler, if you use assembler, all of those can really make you feel a little interesting. But Python is such that it allows for a really beautiful way of putting together the code so it reads like a well-written story. And that's one of the things that I try to help my students understand. Your code should read like a well-written story without the comments. The comments should just be extra. Yeah. All right, so now explicit is better than implicit. In other words, we're going to do it the same way every time without a lot of guesswork. And this kind of speaks to the idea of implicit change. In a lot of different languages, you have a lot of implicit activities, meaning that we're going to change the data type implicitly, which also means I may not be quite sure what's going to happen. Well, Python is very explicit. Like there is no implicit data type change. If you want to change something, you've got to tell it to change it. Amber says, I got my 12-year-old hooked on. Oh, yeah. Yeah. My wife doesn't like Monty Python because I recorded over her graduation when she was pregnant with our second child. So she's not been happy with Monty Python since then. So I'm still trying to live that one down 30 years later. So simple is better than complex. Complex is better than complicated. I know that's almost oxymoronic, but the major thing is readability most certainly counts. So what do we strive for? As we say, we want it to be as simple as possible, as clear as possible, and concise as possible. Well, one of the ways that you can think about Python, everybody, is think about it as just like a basic kitchen. So this is an intro. So I'm introducing you to the basic configuration of your kitchen. You don't have any of those wild things that you might bring in to make any of those really crazy dishes. However, this kitchen is definitely extensible, meaning that you can add what you need to it to do what you need to do. The language itself, everybody, is what we call interpreted, which means it is not compiled. So I want you to think of it from this perspective if you haven't worked with programming before. So do me a favor, give me a yes if you've worked with programming before, even if it goes all the way back to basic. Give me a no if you're like spank brand new. So type that in the chat for me, if you will. Awesome, awesome. COBOL. Oh, yeah, if you do COBOL right now, you are a six-figure individual if you're still programmed in COBOL. They need COBOL programmers. Oh, yes, and a bit of Fortran because the satellites are written in Fortran, and so they need Fortran programs. Well, I'm going to talk about this from the perspective that you don't have any idea about what programming is other than you've heard the word programming before. So programming is a language, and a language, like any language, has to be interpreted by someone or something. Well, the same thing is true with a computer. It has to interpret what you're telling it to do, and it interprets it ultimately in something called machine language. But the question is, how do you go from your language to machine language? Because assembler is like that, a machine language, and that's definitely kind of interesting. And so what we did when it came to working our way through this is we would take a language, and then we would have software that would compile that language into the machine language so that it could then execute on the machine. However, writing code like that is a bit more challenging. It's called compiled. Well, an interpreter requires, an interpreted language that is, requires something to interpret it. And it allows you to just take the regular language without having a need to compile it and then allow the interpreter to do all the work. So the interpreter now looks at the code line by line, whereas a compiled language takes your line by line, compiles it into the machine code, and now it can run. But that creates not only some benefits, but some challenges with your language if it is compiled. One of the challenges is it becomes platform dependent. It won't easily run on all of the platforms. You may have to do different things to the code to make it run on the different platforms, such as Windows, Linux, Mac OS. But with an interpreted language, as long as you have the interpreter that can run on each of those platforms, you don't need to change the code. Well, bam, that's exactly what happens with Python. So By it not being compiled, by it being interpreted, that also means we're going to have to install the Python language or interpreter, or that interpreter is going to have to come bundled with whatever solution we're using. So this is what we call the overall rendering process. You're going to start out with a .py file. That's your Python file. And you start out with a file because once you write the code, you may want to use it over and over and over again. You don't want to have to rewrite it over and over again. Well, once we start out with the file, the assumption is we have on our machine or access to the Python executable. The executable then is going to go through the compilation line by line of our code. Now, the great thing for us is we don't have to worry about the compiling of it. That means, again, that we can run this code on multiple platforms without potentially making any change or very little change to the code. It is converted into machine language, but the interpreter does that for us. And at the end, we get the result. Now, is it slower or faster? The answer is it's slower. Can it be run in a web environment instead of installing? And well, there's going to be an interpreter somewhere, even if it's in a web environment. There's a python.exe that's executing and it's running within that session somewhere. As a matter of fact, we're going to today, as a part of my demos, we'll be using Jupyter Labs, which is going to run through quote unquote a web-based environment. So partly, yes, you can run it through a web-based environment, but also it has to have an interpreter. So you got to have Python exe somewhere. Great question. Awesome. If you got a question, just ask me, everybody. I'll do my best, of course, to answer you to the fullest. Oh, yeah. There we go. All right. So why are we going to use Python? Let's just talk about this. Right now, it's considered to be the #1 ranked programming language in the world as it relates to the people who are using it. Now, admittedly, this language is almost 30 years old. This language is almost 30, well, it's a little bit older than 30 years old, as a matter of fact. But the language is carrying, there we are, so much weight that Microsoft, I'm pretty sure you all are familiar who Microsoft is, Microsoft hired Guido van Rossum to be the spearhead and manager of their Python program. Oh, yes, Angela, it's been out over 30 years. Yes, so it's probably older than you are. It's been out a while. Even I was in my 20s when it came out. Late 20s, but 20s nonetheless. And so we look at the main features of it. Why is it so popular? Well, number one, not only is it productive, but it's simple. And it's still powerful enough to do everything that we want. Now, is it as powerful as C, C++, C#? No, it's not. However, it can be extended and it supports interoperability of C and C++. So you can extend what Python can do, not only with Python, but also with C and C++. Again, you can take this basic kitchen and extend it such that you can do what you need to do. And the example there is where we use modules as well. There's also a ginormous, and yes, that is a word, there's a ginormous community of people who use Python. So as we say, it's the 4th most popular technology right now. We're using it everywhere. And if you don't know any of the others, can you still? Oh, yeah. That's the great thing about it. You don't have to know C#. You don't have to know C++. You can start with Python. Man, your kids could start with Python. And I mean young kids, because it really is that simple to get started. However, it is not pigeonholed or siloed in its simplicity. Sometimes when things are simple, it's siloed to that simplicity and you can't do things that are more advanced with it. Python is not that way. I mean, Instagram was built on Python. Dropbox was built on Python. So it could really meet you wherever you need. And that's the great thing about it. Like I said, easy to learn. The mic drop. Oh, yeah. It's easy to learn. It's object oriented. We'll talk about that. An object, in essence, is a class of items that has properties and methods. That's what we call that. Cover this already, but is it true that if you don't have Linux, you have to create a Python environment in order to use Python? Okay, great question. Great question. I'll answer that right now. We're going to talk about installing Python. So Python comes natively installed in Linux, Unix, Mac OS, because they're all Linux, Unix based. So Python comes installed. Windows, it doesn't come installed. But guess what? You can install it for free. Booyah. There you go. It's just that simple. Or, like I said, you'll get to the point where you may create solutions, and what you'll do, you'll include it as part of the solution. So the user doesn't necessarily have to install it. It'll be included. Those Python bits will be included as part of the bits. Oh, yeah, it's great for all ages, without a doubt. Oh, yeah, as long as you got an operating system, you can run it. Yeah, you can run it on Raspberry Pi. So you can run it on very small form factors. You can run it within containers. You got an OS, you can run it. That's great. And so here we're going to look at some of these functional things that we're doing, such as structured programming. We're going to talk about that if then else blocks. We're going to look at the functional programming here. But there's a dynamic presence when it comes to third-party modules. There are 450,000 plus packages that have already been created so that you don't have to reinvent the wheel. Now, in my opinion, everything that is everything has to have something to do with barbecue, because barbecue makes everything better. And when I went out to PI, which is the Python package index, and found that somebody had created a module for barbecue, I knew I was in the right place. And so there's almost nothing that you couldn't want that you can't find a module for. If you can imagine it, more than likely somebody else has already done it. Let me show you. pypi.org. Let's spell org right. Oh, look at there. I'm going pretty fast. And so it's happening. This is exciting. You know, you've been planning for something and it works exactly the way that you want until you wanted to do it. Nico told me that you can't. Let's see what I'm creating. No. So here is why potentially you would want to have multiple environments. You would want to have multiple virtual environments in Python, because you can have multiple instances of Python installed on the same machine, or you may have different projects that require different configurations of Python and the modules that you're going to need. So it's quite possible that you have one solution that you're working on, and it uses one set of modules, but if you were to upgrade to the next version of that module, it's going to break your solution. Well, you don't want to do that. Or it could be that you want to work with a totally separate version, and you don't want that to then have some sort of interoperability challenge. That's why you create virtual environments. So could it adversely affect the performance on your machine? Well, anything you install on your machine is going to have a hit on your performance. But unless you're doing something that's going to require a lot of juice, normally the answer is you're going to be okay. Yeah. This is the py.pi.org, everybody. py.pi.org. And notice, like I said, there are barbecue. Now, I know you're like, well, why aren't you looking at barbecue? Because it makes everything better. But there's almost nothing that you can't think of that it won't find. So while that's finding it, I'm going to go to the next slide. There it is. Look at that. Somebody created a module for barbecue. That's how I know I was in the right place. So if you're looking for modules that are going to help support you, if you're working with databases, if you're working with Azure, if you're working with AWS, if you're working with your networks, if you're working with managing logs, if you're working with creating websites, whatever you're working with, if it doesn't have a module out there, if you give it a few minutes, it probably will. That's probably what's going to happen. Yeah. All right. So some of the disadvantages. Well, it can be slower because it's looking at it line by line. In other words, It's not as though, I'll put it to you this way. Compiling is like going to the baker or the bakery and getting a cake that's ready made. It's already made, it's ready to eat. The only challenge is you can't make any changes to it. They'd have to remake it again. But it's ready to go. That cake has been compiled, it's ready to consume. So that means you can get to it faster. You can consume it faster. Python is more like creating stuff from scratch every time. So you get more control. It's a little bit easier to deal with, but it may not run quite as fast as compiled languages, and that's true. The way we deal with errors is a little different because you don't know you're going to have an error until you actually run it. When you're compiling, if there's an error, you might see the error at compile time before you run it. So in this particular instance, you might not know that there's something wrong with the cake until you actually start baking it. It's single-threaded. Single-threaded just means it really works with one unit of execution. It's not multi-threaded by default. But guess what? Somebody's put a module together for that. So they're getting it done. So how do you get started? You just go to python.org. If you go to python.org, you can download it. It is literally that simple. Okay, so let me go out here. Wait, look at that. So just to show you. Python.org. And here it goes. Here it's happening. It's happening. Now, I will give you a tip right here. Don't tell anybody that I told you. The size of this window can really change the context of the menus. So I tell anybody, whenever you're working with the browser interface for python.org, it's actually easier if you work with it when it's completely expanded. If not, it changes the way the menus look, and it's horrible in my opinion. But here you got your downloads. So right now, as you can see, 3.115 is the present version, which would be the latest version. When you look at your versions, 2.7, then it went to 3, then it went to 3, then it went back to 2.7 because there were some incompatibilities. And now most people are probably using like 3.6. Yeah. But based on the operating system that you're hitting python.org from, it'll try to guess the appropriate install. But if not, you could look at all the releases and you'll see you'll have Windows, Mac OS, and Linux that you can install it to. And you can get to the different versions that you want as well. And so it is really that easy to access and install. Yeah. Now, if you decide that you're going to go with a bundle, if you're going to bundle it, you can install Anaconda. Now, Anaconda, everybody, is what we call a Python framework. And what it allows you to do is it allows you to set up your entire Python environment. It can make it easier, potentially, to manage the virtual environments because it's easier and more straightforward to create the virtual environments. You can have multiple what we call ISEs, IDEs, integrated scripting environments, or integrated development environments that you're going to use to develop through. And so it gives you one single pane of glass. That sounds like a geek, doesn't it? It gives you one single pane of glass so that you can manage Python through. And it's mainly focused on data science. To me, it's kind of big. And it does put some stress on your machine. I don't use it, but a lot of people do, especially if they're in data science. All right, now we talk about getting started. We said that there was a 2.0 version. We're in the 3.0 version. We're using 3.11.5 right now. You can have multiple instances installed on your machine. This is where you can work with the virtual environments. We won't have an opportunity to get into that. But one of the things that you will do after you get installed, you can do Python-V. And what Python-V will show you is it will show you what is considered the default version of Python on your machine. This is normally associated with what we call your environmental variables. See if you can see both of these fingers here as I do my air quotes. It actually deals with those environmental variables. If you're on a Windows machine, just as a tip, you've got two categories of environmental variables. You have user environmental variables and system environmental variables. User environmental variables work when you have multiple people using the same machine. So you probably won't do it that way. You'll probably set it up through the path variable in the system environmental variable. That way, your system will automatically go to that location to use Python. If you had different versions, you would point explicitly to the directory that contains the python.exe that you want to use. That's another way of doing it. Outside of that, you would create what we call virtual environments. All right, so now what does the scripting environment look like? Well, we have this thing called the REPL. The REPL allows you to read, evaluate, print, and loop. That means it's going to read one line at a time. It's going to evaluate it one line at a time. If there's something to be displayed, it's going to display. And if it needs to keep going, it will loop. It's called the REPL. So when you're working with Python after it's installed, you can go into what we call interactive mode. Now, what I will tell you about interactive mode is it is definitely a bit more interesting to use, to say the least, if you're using interactive mode. Now, you're going to see me make a little change here. All right. And so if I say Python, I'm typing. I really am. This is super exciting. All right, give me 1 second if you don't mind. There it is. Just took a second. It's brought up a new window. So hopefully you can see that. It's coming up. There we are. Now, if you're using Windows 10, 19, 06, and above, or Windows 11, the Windows terminal is awesome. I'll just add that little plug there. So if we type Python here, dash. Now, one of the things to remember is Python is super case sensitive. So at the present time, I'm using Python 3.11. Yeah. And if I type Python now, just the word, shabam, I'm in what's called the interactive mode. But this is a hard mode to use. It doesn't do a copy and paste. It doesn't really deal with IntelliSense. It doesn't give you a lot of help. There are some people who love to do it this way. Those hardliners, they love doing it this way. Me, I don't, because it doesn't take much to confuse me. And that's one of the things. And so with that, we're going to use some of the other integrated development environments. Now, one of the integrated development environments that you have is built into Python. You'll choose to install it when you install Python, or you can go back and install it later. It's called IDLE. It's the Integrated Development and Learning Environment. It's actually written in Python. And what this will allow you to do, it will allow you to bring up an interactive shell. But not only that, it offers you the IntelliSense as well. So in the interactive shell, that is for IDLE, if I type print, it will literally give me the syntax for whatever function I've typed. If it's a built-in function, it'll give me the syntax for it and tell me, hey, potentially this is what you would like to add to it. And it's free. Now, when you're working with IDLE, everybody, if you should decide to install it, and I suggest that you do, there are actually two windows. One window represents what we call one window here. If you can see on my right, this window represents the interactive window. The window on the left represents where you would write your code. Those are the two windows that you would work with. So like I've got a window here for the code. I got a window here for interaction. Now, in this particular window, what I did was I created a script that allowed me to work with a function. And the only thing it's going to do is going to say hello. And so if I execute and then by using run and then run the module, You'll notice in the integration window, this is where it's going to actually execute as it's running super fast. Oh, that's exciting. So let's see here. I'm writing now in the interpreter itself. Notice that it has color coding. Let's see. So here's what we're going to do. We're going to do the old-fashioned. Restarting it. Yeah. If you've installed it, you should be able to search for it. And it'll show up. Like here's idle. I've got multiple versions of Python installed. I should also be able to go to, now this is 10. If you've got 11, you should be able to do the same thing as well, though. And there is 311. As you can see, I've got 27, 37, 38, 39, 310, 311. I got them all. Well, quite a few. And then when you choose idle, what will happen is it will literally open the interpreter first. Yeah. I think Zoom is getting me. Let's try it again. Print. Will one idle version conflict? No, not really. Not really. It's just going to use the version of Python that it's associated with. So you may have whatever access to whatever features are available, but other than that, it doesn't conflict. That's why it says it's really great that you can run all these things together. Do you use single quotes, mess it up, or was that? It doesn't matter as long as you're consistent. This is one of those things where Python is very explicit. A string is a string, whether you put it in single quotes or double quotes. It's not like some other languages that make a difference. So here, I put this in single quotes. Let's see if it's going to, yeah, there it is. Hello, world. If I spell hello right. Or, again, I could do it with double quotes. Oops, excuse me. Double quotes as well. The only thing is I need to be consistent. If I attempted to, let's see. You see that? Now it says I've got some sort of income. I've got a syntax error because it's looking at that first single quote, is looking for the single quote that matches it. So as long as you're consistent, bam, Jerry, it works. Oh, yeah. All right. So some of the environments that we have, like I said, we got Anaconda. That's an environment. You can download that. That's free. They got a free version and a paid version. PyCharm is another environment. That's the environment that we use when I teach the class, although it's not the environment that I tend to use most often. Spider is an environment. JupyterLab, which I'm going to show you as a part of what we're doing today. You have Visual Studio Code, which is my favorite of all times because it's very flexible. It allows us to do a lot of work. Excuse me. When it comes to the interpreter, everybody, you got the basic interpreter that I just showed you. But if you install what's called IPython, which can be installed as a standalone item, as a part of Anaconda, or with JupyterLab or Jupyter Notebooks, it actually gives you a little bit better look on it. So let me exit out of this if you don't mind. I'm going to exit out of here. I'm going to type IPython. And this supports copying and pasting. It supports IntelliSense. So it can be a lot better. And you can see the visual there is a little different. Yeah, but I'm still going to do the same thing. But see, now I'll say print. Notice it says, hey, that was the last thing I did. Print. Hello, world. Bam. Oh, yeah. And in this interface, even though I'm going to talk about help, I can type a question mark. And if I want some help on something, I can say question mark Here's the item I want help about, and shabam, look at that, gives me help. And the great thing about it is it could be at the beginning of the word I want help for, or at the end. It doesn't matter which end I put the question mark on. It just works. That's beautiful. So I really like the IPython interface as an interpreter. It can make life a lot easier. If you have written code, you can access that code, meaning that I could specify that I want to run a particular .py file. And so in this example that you see here, what I did was I said Python, then I literally specified the item that I wanted, and I executed. And that was just hello world from the function. That's all. Now, comments. Comments are a really, really important thing. Comments are important because 6 months from now, you're not going to remember what you were talking about anyway. You'll just know that you were a genius. That's it. So comments are marked with inline comments with a hash mark. We don't really have quote unquote block comments like you're seeing other languages, but what we do have is what we call doc strings. And this takes us back to the single quote, double quote conundrum. A doc string, now you'll note here, I've got the inline comment that is preceded by a hash, but the doc string allows you to maintain the format, and you can have multiple lines as long as you have 3 single quotes, your string ending with 3 single quotes, or you start with 3 double quotes, your string, and then you end with 3 double quotes. And that's called a doc string, which can also be used like a block comment. So that way you can make sure you're going to remember what you did before. Help is something that is important because there's a lot of stuff that Python can do, of course. And so PyDoc is a module. Now think of a module as a container of work. It could have functions, it can have classes, it can have variables, but think of it as almost like a drawer that has different components that you need such that you can extend what your kitchen can do. Well, PyDoc happens to be one of those, and it can allow you to get help with what's happening in your environment. So we have PyDoc. Help is a built-in function that allows us to get help. If you're using IPython or Jupyter Labs, as you saw, we can use that question mark. But we can also look for types and directories as well. If we then look at, this is Jupyter Labs. Now, this is the example of a web-based environment that is actually using Python on the back end. And you can run this on your machine. If you install the Jupyter Lab module, the Jupyter Lab module will then allow you to run Jupyter Space Lab, which will pop up in a web interface, and you can go to town without having an additional IDE installed if you don't want. And so here you see where we have the doc strings, but here's the help. Now, the great thing with this is if I want to run something as though it's a command line, if I'm in Jupyter Lab, I have to use a little trick. I have to put an exclamation point in front of it. Now, each of these things is called a cell. And so what I'm going to do is I'm going to hold down the control key and hit enter. If I do control enter, it only executes that one single cell. And so what you see here is I'm going to execute Python-M, which means I want to execute a module. The module that I want to execute is PyDoc. And it literally shows help about PyDoc. And shows me I can get PyDoc for a particular item, a particular keyword, or I can have it start up a web server as well, which can really make it easy. So in this second example that I'm showing you, what's happening here is I want information about the if command. And there it is. Gives me good help about if. So this works in Jupyter Lab again, and this works in IPython as well. But it's also possible for me to start up what's called a server. If I start up the server, it gives me a complete interface of all of the available modules that I have for the instance of Python that I'm using. And so the cool part here is it's going to spin this web server up automatically. Now, the only challenge with doing this in this interface is that even when you close out of it, you're going to have to what we call restart the kernel to get out of this. But look at this. Here's all your help. If you wanted help on anything, if I want to help on the OS module, all I have to do is point to it, click on it, and like magic, it's going to show me everything associated with it. It's awesome. Help is going to be your friend. However, the truth of the matter is you're going to use Google and Chat GPT. Yes, you are. People say, I'm going to use Chat GPT. I hope you're using Chat GPT, because if you're not, you're going to miss the mark. Yeah. Just remember this. Yes, Ron, use Chat GPT. It's like Google on steroids. It just cuts a lot of time out. You still got to have the basic foundational knowledge to use it. So it's not cheating. Trust me. It's not cheating. It's not cheating. All right. Now, if I use type, everybody, and I notice I got type barbecue here. When I use type, stop reading on it, Ron. Just use it, man. Just use it. It's free. You can't beat that. It's tough to be free, man. Just use it. Yeah. Tell me. All right. And so here, everybody, I am looking at, I want to see what type a particular item is. Oops. There we go. Let's try it again. And what type will do, type will literally show you the type of object that you're working with. Mm-hmm. Okay, two things you got to watch out. These are what I call the two trip ups. Here are the two trip ups. The two trip ups are, number one, is case sensitive. Python is very case sensitive. That's going to get you. Number two, indentation. Whenever you're working with what we call blocks of code, indentation will get you. Now, most IDEs want you to indent by 4 spaces. And so it'll automatically indent when you have what we call block code. Well, when you write your statement, what is a statement? A statement is nothing but an expression. X equals 5 is a statement. Print X is a statement. And it resulted in it printing out the value 5. So it's nothing but an expression. White space. Well, the white space is this idea of indentation. All right, so if we look here, we have what's called a conditional block. We're saying if X equals 5. Well, again, we said that Python is very explicit. In other language, the equal sign has what we call contexts, meaning that it can be used for assignment and it can be used for comparison based on how it's used. Well, Python doesn't do that. If you're using it for assignment, it's a single equal sign. If you're using it for comparison, it's 2. And so there's no question about it. So here I'm saying if X equals 5, then I want you to print. Else, I want you to print X is not equal to 5. Well, this is what we call a block statement. And what I mean by a block statement is, if you will look right, kind of. You remember Pascal? Yeah, kind of Pascal-y. It sort of feels like that just a little bit. But if you look, there's the colon. That colon, that you use it daily. Oh my goodness, man, I hadn't used Pascal since the 80s. That colon represents a block, which means I'm going to indent this by 4 by default. And so whatever IDE you're in, normally if you try to indent by something less than 4, it'll actually give you an error, even though you haven't done anything wrong. All right, the next thing we're going to talk about here is like a variable. So what is a variable? A variable is just a temporary storage place for information. It represents a pointer in memory. Is it case sensitive? Everything is case sensitive. Just keep that in mind. Everything is case sensitive. So your variable names are case sensitive. Now, what you don't have to do if you come from another programming language, you don't have to worry about what I like to call pre-typing it. I don't have to define the type the variable is before I use it. I don't have to declare the variable. Declaring the variable is dynamic in Python, which means I can just specify the name, assign a value to it, and it'll pick up the data type. It's like magic. And so here, FOTG, in case you didn't know, which means food of the gods, is barbecue, of course. So I've got a variable that I've assigned a string to. I've got X and Y that I've assigned numbers to. And then result, I've got a variable that I have assigned an expression to. Now I can print all of those items. I can print the result, which is the result of an expression. I can print FOTG, which is what we call a statically assigned value. But in any event, it's a variable. It's a temporary storage area, and we use it all the time. This takes us into this idea of an object. So in Python, everything is an object. Everything is an object. And since everything is an object, what we have to remember is that it kind of works with this thing called a class. That class has different objects, which allows us to describe stuff. And in describing stuff, we have what I like to call the context stuff, properties. And you can have methods. This kind of defines what that object can do. I tell people properties feel like adjectives. Methods feel a lot like verbs. Well, when you're working with this stuff in Python, it can be a good idea trying to figure out what these items are. To figure out which properties and or methods you have associated with an object, you can use the dir function, dir. It's almost like the directory function that we use when we're working in Windows. But it'll show you all of the methods and properties. If you needed to be a bit more specific, I wrote this piece of code here. I'm going to work to see if I can get you all this, and that way you can have this file that I'm using. This allows us to look at the individual attributes. Now, this thing right here is called a list comprehensive. So at the present time, don't worry about it so much right now. But it gives us a really fancy way that we can write an if statement. And so I'm looking at a for statement that is allowing me to look at what we call a collection. We're going to look at here in a second. I'm assigning those values to a variable called attribute. But before those values get assigned, I'm actually looking to see that the attribute doesn't start with a double underscore. Now, excuse my lines right there. And I'm trying to make sure that it's callable. That means I want to see if it is a method. And then that way, it'll return just the methods. Another thing that we can do is we can go with that whole module piece and import a module called inspect and do an inspect.getMembers. This is a representation of a class that has a method. GetMembers is a method, as we talked about class and objects. And we're going to pass it a parameter here, FOTG, which is that variable that we assigned barbecue to, and it'll tell us then what the properties are. Now, as we go with the Python operators, everybody, one of the things that we see here, we have arithmetic operators and we have assignment operators. And you've probably seen things like this before. Please excuse my dear Aunt Sally. That order of operation is still in place. But this allows us to manage and control our expressions within our environment. And so you have arithmetic, and then we have what we call comparison and or Boolean operations. Now, a comparison operator results in a Boolean expression. When you compare something, it either is going to be or it ain't going to be. If I say 1 equals 1, that's true. If I say 1 equals 2, that's false. And so we're going to be looking at those Boolean comparison. These are the data types that we have. One thing to remember about a data type is a data type represents what we would call the lowest level constraint that we would be working with in an environment. And these are our data types. So we got Boolean, int, float, list, tuple, string, and set. The one thing that I would have you remember is that when we work with list, tuple, strings, set, frozen sets, and dictionaries, get all of that, these are called our data structures. These are what we often call arrays that allow us to hold sequence of values when we work with that. Now, you'll see, I'm going to work to see if I can get you access to this PowerPoint as well, because I kind of laid it out as just as a mini walkthrough for you. But it gives you an idea about how all the types work together. If you're using X as an integer, but later try to pass it a float, what happens? It turns into a float, run. It'll overwrite it. That's exactly what happened. Yeah, it'll overwrite it. I'm gonna do my best. I can't make any promises. My wife taught me under promise and over deliver. So we'll see what happens. So if it doesn't happen, don't get mad at me, but I'm gonna work real hard for it. Trust me. And so we talk about our object types. We got the primitive types. These are what I often call the default types of things that we deal with. So we got integers, we got reals, we got floats, we got things that are strings, we have Boolean, true, false. And so here we're saying Boolean 55. That means if it has a value, it's considered to be true, or if it doesn't have a value, or if it's null, which we call none in Python, it's considered to be false. Now, our object types data structures, these represent our sequence items or arrays. So even in looking at the way this is laid out right here, there it is. We say array, but all of these things represent, except for files, well, even files can represent an array of items. And we call those non-primitive because they're really data structures. Mm-hmm. So our built-in data structures are arrays, lists, and tuples. And that just really talks about how we're going to manage the structures themselves. So of these sequence or arrays, we have lists, tuples, sets, and dictionaries. And you will note you can kind of tell what something is by the way it's represented in the expression. If it's in square brackets, it's a list. If it is in parens or it doesn't have parens, it's a tuple. If it's in curly braces, it's a set. If it's in curly braces where you have a sequence of items where you have one item separated from the second item by a colon, that's called a key value pair. It's a dictionary. And so this allows us to represent data in different ways. Well, I kind of put this together so that you can see how all of these data structures work together as well. So it kind of gives you an overall picture of what's happening. Now, displaying on screen. One of the things we do on the screen, of course, is with the great print. Print allows us to print things to screen. And it can allow us to print multiple objects. We separate each of the objects by a comma. But we can also then define the separator. If we don't specify the separator is a space. But if we do, the separator will be whatever we define it to be. And you can also define what's going to occur at the end. By default, \n means it's a new line. And so that's what we have by default. One of the other things that we have here is our control flow. Now, with the control flow allows us to specify what we call an if condition so that we can make the application appear to be somewhat intelligent. And so that's why we use a conditional statement. But the same thing is true. You have the condition, the true position, and the false position for the if statement so that you can then make this thing look smart. The other thing that we have is a control flow. Now, a control flow, everybody, represents what we call iteration through a loop. And the way to think about this loop is to think about it like a container. In the container, we have something. So I gave you this picture. I've got a fruit basket, which represents the container. It can contain apples, pears, grapes, and oranges. And now I can say for fruit in fruit basket. Well, fruit here that I have actually represents just a temporary variable. And it's like we're going to be picking one piece of fruit out of the basket at a time. And every time we pick a piece of fruit out of the basket, we're then going to print it. So this means that it allows you to go through a collection of items and then do something for each item in the collection. That means if you don't know how many items in the collection, you can still work with it. Then we have what we call our while loops. Now, with our while loops allow us to do something until a condition changes from true to false. What's true to false? Whatever you define it as. Here I said count equals 0. While count is less than 5, we're going to print count. And then we're going to increment count by 1. So count plus equals 1 is the old C way of saying count equals count plus 1. And it's going to give us 0, 1, 2, 3, 4, 5. Now, we can't have functions. I won't get into functions so much. The last thing that I want to talk about here will be modules. And the module, as you saw, allows us to extend what we can do with Python. It adds functions, classes, and variables so that we can extend what we can do with Python so that we can move forward. And we can import those modules by using the import command. If we do use the import command, it's going to give us access to all of the functions, classes, and variables. But we can also augment this by saying from module name, and we can import just a single item that we want. And then that way we can cut down on the potential for confusion. Well, everybody, that's all I got for you in this hour. It's hard to believe that an hour went by so fast, but it's been fun. So, Brandon, take it away. Oh, my pleasure.
Well, thank you so much, Charles. If everyone can give a thank you in the chat or an applause as a reaction, we just want to show Charles our appreciation for this last hour that has been extremely informative. So thank you so much, Charles.
My pleasure. My pleasure.
As you can see on the screen, I've gone ahead and put Charles's web or email address on the slide. So you're welcome to email him with any follow-up questions you may have. Now, you are also welcome to follow us on LinkedIn. We have tons more events just like this, and we have a lot more resources available to you to be able to support you as you're learning about Python, coding, whatever in the IT world. We are here for you for that. After you leave this webinar, you will get a one-question survey asking, would you like to continue the conversation? And that just simply is asking, would you like to learn more about New Horizons and how we can support you and your company in your development and in helping you guys move forward in this tech-first world? So if you are interested in that, go ahead and say yes. We'll then get you connected with the right person to be able to discuss how we can support you in that. So if you have any questions at this time, Charles has just a few minutes to be able to answer any questions you guys have, and we can go from there. But thank you all so much for coming today.
Oh, Angela, barbecue is the best. Oh, thank you. Yeah, I do voiceovers on the side as well. So in a world where Angela gets all the barbecue she wants, wet, that's the only way to go, Ron. I'm a Southerner, good Southern boy. Yeah, but everybody get excited about Python because it's everywhere. It is everywhere. And like I told you, Microsoft thinks so much of it that they hired the guy who created it. So that means that there's got to be something to it. That's correct, Amber. If it ain't messy, it ain't no good. As the guy said, meat and bread. That's all I need, meat and bread. What could be a beginner exercise? One, man, there are 5,432 decent sites out there to get started with. You could literally start with python.org. They have a great listing of sites, and they'll take you from sites that'll help you as a beginner, intermediate, and advanced. To me, that would be the best place to start. What is the best environment to start with so many options? It depends. It depends on how much flexibility you have with the install. So I like Visual Studio Code, but it's got a bit of a learning curve to it. It does. You could literally start with the built-in idle. It's good. It's got IntelliSense. It has coloring. It has debugging. It has all of that. And it's a really minimal, thin install, light install. PyCharm is that's what I teach on. PyCharm is good. There's a free community version of this. It's got a little bit of a learning curve as well, but probably not as steep as Visual Studio Code, because Visual Studio Code allows you to do more than just Python. My suggestion is that if you are in a Windows environment, that you move toward Visual Studio Code, because that's going to open up a plethora of options, not just Python, but allowing you to do other things that you might want to do interoperably. I've had trouble understanding graphs and charts and Python. Any good resources to help me learn? Okay, Amber, that's where we get into Matplot. Matplotlib would be the thing that you would get into on that. And so if you just do a web search for basic Matplotlib examples, you can find examples on Matplotlib. And that's where you're going to get into visuals. Now, here's my opinion. Some visuals you can't beat Excel for. You just can't. It's going to give you everything that you need, kind of all bundles together. If you really need web-based environments where you're facilitating web-based environments for visuals, if you've got more complicated integrated and you need more control, then definitely Matplotlib is something that you're going to be going for. I just added Python to my Visual Studio. Oh yeah, Ron, I'm telling you, Python is so popular. It is the number one. It is the number one extension for Visual Studio Code. You would think it would be C++, C# or Visual Basic, but it's Python. It's the number one extension. So it works really well. Let's see. Well, R is good. R is primarily meant when you are working with statistics, but Python is really encroaching on it because Python can do just about, well, it can do all that stuff plus anything else you want it to do. So now when you look at the potential of creating a more holistic environment where you need the statistics, but then you need to display it, or you need to store it, or you need to deal with extraction, transformation, and loading of it, Python does all of that. So if I need to display it, I got Matplotlib. If I need extraction, transformation, and loading, I got Pandas. If I need machine learning, I've got TensorFlow, scikit-learn. I mean, it just creates an entire, it's almost like Walmart or Costco or something, where if you need it, it's probably in the store somewhere already. It's not a boutique. R is more like a boutique piece. If I follow, when you ask me about the Replit, I'm thinking what you're talking about. If I'm following, that's just the whole idea of the REPL, where it looks at how it's going through the code. Let's make it. That was my next question. Yeah, amazing stuff. Thank you. Oh man, it is my pleasure, Ron. I love doing this. I can't believe I get to do it, and I want to thank each of you all for allowing me the opportunity to be of service. I really do. Oh, have a great day. Be safe. Take care. Do some Python while you're at it, along with some ChatGPT now. All right, everybody, until we meet again, you all have a great and wonderful rest of your day. Bye-bye.